Hi, welcome back, Intro Stats students. So today we will be doing this exercise, making conclusions in a Z test for population. Okay, so right here we go. Antonia read an article that said 26% of Americans can speak more than one language. So she was curious if this figure was higher in her city. So she tested. Now that's the null hypothesis, right? Null hypothesis H naught dot dot colon, and then this is the population proportion, right? Population proportion that she's claiming that 26, or the article claims that there's 26% of Americans who can speak more than one language. So population proportion equals to 0.26 versus alternate hypothesis. The alternative hypothesis is P is greater than 0.26 because she says here she was curious if the figure was higher in the city.
Can you please call the front office?
So,
385-646-6300. Mr. Snyder, your 2:15 appointment is in the main office.
where P, population proportion, represents the proportion of people in her city that can speak more than one language. Antonia took a sample of 120 people in her city, found that 35% of those sampled could speak more than one language. So 35%, well, it looks like there is enough evidence, right? It's more than 26, 35 is more, but how much more? So is that enough, right? It's almost a 9% increase. But this is only from one sample, though. How likely is that sample? Did it happen by chance? So, all right, we are supposed to calculate. So the test statistics for this results was the test statistics, Z statistics is approximately 2.25. And the corresponding p value was approximately 0.01. Good. Assume that the conditions for inference were met. Is this sufficient evidence? So, ladies and gentlemen, this is where you need to pay attention. So, your p value, right? Your p value, if your p value is less than alpha, right? We're gonna reject. We will reject the null. If p value is greater than alpha, we fail to reject, right? We fail to reject H naught. So is there sufficient evidence? So check this out. So here we have the p-value is 0.01, the alpha, the level of significance or the significance level is 0.05. So it's obviously less. The p-value is less than, so we reject H naught. We reject H naught. So here it says here, so if we reject H naught, we are concluding that it's greater than 26%. Yes? So, yes, right? We're concluding that it's more than 26%. So, it's not C, it's not D, it's A because the significance level, sorry, the p value of 0.01 is less than 0.05. That's your alpha, that's your significance level. Okay, well, let's look at what the explanation goes. Since the p-value is less than the significant level, alpha, the correct conclusion is to reject H naught and accept HA, right? HA is alternative hypothesis. So there is sufficient evidence to conclude that the proportion is greater than 0.26. Ava read an article, right? Read an article claiming that 10% of people in her county were senior citizens, and she wondered if this held true for residents in her city. She took a random sample of 225 people from her city to test. So H naught. The H naught is the population proportion that are citizen, right, senior citizen, zero point 0.1, versus H naught, sorry, HA, the alternative hypothesis that it's not equals to zero point 0.1, right? So, so why is it not equals to? It says here she wondered if this held true. So if it's not true, that means it could be less than 10%, it could be more than 10%. So this is a not equal sign, not equals to zero point 0.1, which is a two-tailed test, right? A two-tailed test, where P, population proportion, is the proportion of people in her city that are senior citizens. However, found that approximately 14% of those sampled were senior citizens. So 14%, that's your sample proportion. She conducted an appropriate significance test, and the resulting test statistics was Z statistics is approximately 1.89 with a corresponding p-value of 0.06. So this is greater than your alpha. So if it's greater than your alpha, is there sufficient evidence to conclude that the proportion of city are that are senior citizen is not 10%? So we failed to reject, right? We failed to reject. Is there sufficient to conclude that the proportion that is not? No, we don't have, because if we fail to reject, right? If we fail to reject uh, the your null hypothesis, so if we fail to reject, we are saying, we're claiming, we're concluding that the proportion is indeed zero point 0.1, it's indeed 10%, right? So zero point 0.6 is greater than 0.05. So it's not A, it's not D. We got to decide whether is it yes or no, but it has to be more than zero point zero 0.05. So it's this one, right? No, right? We are saying that the senior citizen is not 10%. Um, do we have enough? Oh, sorry. Do we have enough evidence, right, to say that it's not? So no, we do not have enough evidence to say that it's not, because we did not reject the null, and the null is that the p is equals to 10%, right? And the reason, because the p value is less than your significance level. So hopefully this makes sense. You just have to compare the p value to the alpha value. And if you have any questions, do let me know. Thank you.